When we talk about light in relation to plants, there are many different wavelengths of light. You've seen a rainbow or a prism where you have red and orange and yellow and green and blue and indigo and violet colors. That's called the spectrum of light. And there are also spectra beyond which we can see. Well, not all wavelengths or spectra of light are there to enable a plant to photosynthesize. There's only a few specific wavelengths of light in the spectrum that the plant can use to actually make photosynthesis and to make things happen. But when you think about it, everything is ultimately solar powered. You, me, the dog, the plants, everything. You know, without sunlight, everything's going to grind to a halt pretty soon. Getting back to the stomates, those little windows in the plant, the opening and closing of those stomates is regulated by things called guard cells. Guard cells are specialized cells around the little pore in the leaf. And when it's nighttime or when it's hot and dry, the plant will close the stomates using the guard cells like this. And then when conditions are favorable, when the sun is out and the moisture is good, the plant via the guard cells will open the stomates. So the plant can control the opening of those stomates, but that's one of the main functions of potassium in plants, is potassium regulates the opening and closing of the stomates. When a plant doesn't have enough potassium, it can have trouble closing the stomate. When it gets hot, it can't close the window. So what you often see as a symptom of plants that are potassium deficient is you see little dark spots in the leaves. What those are simply are spots of localized desiccation or drying out in the leaf where the plant was unable to close the stomate when the drought stress episode occurred. And so you get these little spots, especially in the old leaves. Sometimes you also get marginal scorch. Some plants are very heat sensitive. I'm actually sensing something in these plants right now. I don't know if the camera can pick it up, but you see how this leaf is kind of folded over and curved? This plant's a little dry today, and it's warm today. It's well into the 80s here in Orlando, Florida. So these plants are actually bending their leaves to avoid some of the sunlight. They're trying to reduce their moisture loss, not only by closing the stomates, but by orienting their leaves such that they're not picking up as much sunlight, and that's why these leaves are laying over a little bit like this. If I were to come back 3 hours ago when it was cool and damp out in the morning, those leaves would not be oriented like that. That to me is a rather fascinating way that a plant can adjust itself, even though a plant cannot get up and walk away when it's uncomfortable. I remember seeing a bunch of Dracaena fragrans mesangiana, commonly called the corn plant, the ornamental corn plant. I remember seeing them in a hot greenhouse one day, and they have long tapered leaves about the length of my arm. And in the heat of the day, the leaf will actually twist like this to avoid the sunlight and to protect itself from excess sun until the sun gets lower in the sky later in the day, and then the leaf will actually go back like this. That's an example where plants actually have the ability to move somewhat. Plant tissue in general, depending on the plant species, runs between 80 and 95% water. So you can see how important water is to a plant's life. Now, the moisture absorption process in plants I find rather interesting. If you would imagine my fingers to be the root system growing through soil, in a normal situation, the salt levels within the root cells are higher than the surrounding soil moisture salt levels are. Therefore, moisture goes rather easily from the soil into the root cells just by osmosis. The plant doesn't have to work very hard to take moisture in. Osmosis is a physical process. So the moisture naturally goes from an area of lower salt index to an area of higher salt index. The water therefore enters the root rather passively, and then it goes into the stems and up and ultimately out the stomates in the leaves. And that process, sort of like a drinking straw, just continues all day during the day, wherein the plant takes in moisture and it goes through and up and out. Now, if we start to add fertilizer salts around these roots, that osmotic advantage that the root cells had before is now lost, so that the root cells are now not saltier than the surrounding soil. In fact, the surrounding soil can be higher, and therefore the roots have to work hard to take in moisture. If you put enough fertilizer salts around the roots, moisture is actually pulled out of the root cells back into the soil by that same osmosis. That is how fertilizer burns. When you burn a plant with fertilizer, it's not that the plant takes up too much of something and somehow injures itself. It's not like the plant starved for a week and then ate 7 pizzas. It's not that way. What happens simply is the moisture is pulled out of the root cells back into the soil, which is why plants with fertilizer burn look so much like plants that are dry, because they actually are. The soil is moist, but because the soil is salty, the roots can't take in the moisture and the plant suffers from drought stress. And it doesn't take very long for a plant to show drought stress when you realize that plants are 80 to 95% water. There's another situation that plants undergo sometimes. Let's imagine it's a very warm afternoon and it's bright and sunny. The plants are pumping a lot of water in order to maintain their hydration. And then let's say that it suddenly clouds over and cools off and maybe starts to rain a little bit. Temporarily, the plants are pumping more moisture than can escape through the leaves. What happens is the excess moisture exudes or comes out through what we call the intercellular spaces. The extra moisture simply comes out the underside of the leaf surface. And when it does that, it leaves these little brown blisters, which we call edema. And that's what causes edema in plants, and ivy geraniums are rather well known for having edema. People get edema too. If you rake leaves all day, you get a blister on your hand, that's a form of edema. If you sprain your ankle and it swells up, that's also edema within a human, and plants have the same condition, although it looks a bit different in plants.